move on. Chapter 15. Now we focus on the what we call the surface area. So this is chapter 15.5. So we skip the application. The application part on the double integral. So we directly go to the surface area. So what is the surface area? So if we see here, let me start from this one. So let's say we have the surface, the blue one, okay, and then we would like to know the surface, the total area within the surface. Okay. Of course, we can estimate. And how do we estimate? Basically, it's similar to what we have before. We cut small part of the surface, and then we project the surface into this xy plane, and we get this small rectangle here. We call this small rectangle as delta A. So then the definition from here, we can say that the tangent plane. Okay, so suppose that the red color, this red color here, suppose that this is the tangent plane. Okay, tangent plane to the surface. So tangent plane. Let's say tangent plane S to one point P ij, that is the point that we would like to evaluate, is approximate or is approximation to surface S near that point. Okay. So what does that mean is the tangent plane, if we look nearby this point, they are plane. The gap between the plane and the surface is very low. Okay? If you look the point here, nearby this point. Okay. So the second important point from here, we call this delta Tij. The delta Tij, this is a part of tangent plane that lies directly above the rectangle below, the Rij. And we say that this delta is approximation to total area of S. Okay, so this delta T, which is, so if we see the tangent plane in a whole, the tangent plane will be that much, okay? And it's touch one point, this point P. So the tangent plane here, okay? And then we take some small part from the tangent plane. We say this is the delta T. Okay? So delta T is the part of tangent plane that is projected through the xy plane, and we have this rectangle. Okay? And now, from the delta T, we are going to approximate how large the area will be. Okay? So we say that the area will be the limit Si m n going to be infinity of the sum this is delta Tij. And now, to find the formula, okay, what is the delta t? So this is not like if we just write the delta t, we need to define what will be the delta t in more clear and concise, precise number. Then we define the delta t as a vector. Okay, so we are having this delta t as a vector. So delta t can be created from vector A and B. Okay, so we have two vectors from this point P. So we need to define that the delta t by definition, the area will be defined by the vector A cross the vector B, okay, and the magnitude value of those results. Okay, and remember that the partial x and partial y both are slopes of tangent lines through point P, ij, in direction A and B. Maybe let me write in more. Okay. So, using this partial x and partial y, we can write that the vector A will be delta xi plus partial x xi yi, the point, and then delta x k, and b will be delta y j plus partial y xi yi, and then delta y k. So this practically, so if you confuse on what is A and B, you could look on these vectors A, B, A. So these vectors, if we describe in three axes, look at A. So A has a, in x-axis it's a delta x. But in terms of the z-axis, it has this, right, which is going to be, so the slope is partial x. Okay. So this will be, how to say that, the z over x, right, z over x. So z over x should be equal to partial x. So z is partial x multiplied with the delta x. So that's why we have partial x delta x. So from this, or if you see from this part, okay. Let me get to, if we divide this between, make it like a triangle like that, you see? So this, so partial x, partial y, both are slopes. Okay. So for the k axis, which means it's the z, so the height difference, z over x or z over y, that will be equal to our slope. So we could write z equal the slope multiplied with the delta x. Okay. Or in this partial y, it's multiplied with delta y because we focus on y. And since for each a and b, for a there will be no y, right, because there is nothing on the right side, right? From here it's only this part. For b is only this part, right? So there is no x, and for a there is no y. And from this A and B, we are going to cross. Okay, so we are going to cross this both A and B. Let me put this later. Let me show you how we get the A and B. Let me resize, or maybe let me resize this part. Okay, let me resize a little bit. Okay, now let's take cross. So A cross B. Anyone know how to cross? Do you still remember how to cross? We take I, J, K, right? And then we put all the formulations for A, B. So A is the first row, right? So delta X, J is 0, and K is partial X delta X, right? And the second row, so this will be, okay, this will be 0 delta Y, and then partial Y delta Y. Okay, at least there are I think several ways to compute the cross. You remember, we can compute this I multiplied with determinant of this, J determinant of this, and K determinant of this, right? Or I will show you. I think that for me it's pretty. I believe it's much more simpler. I will write I and J on the right side. Write the same thing. Okay, and every parts we are going to cross multiply. So I with that, J with that, and then K with that. So we compute all. So I with 0 is 0. So J 0 0. So K delta X delta Y positive, right? And then we cross multiply the other part. So this J, okay, and this I, and this is 0, like that. But we need to take that as a minus, okay? Minus all of that, partial Y delta X delta Y, plus partial X delta Y. Okay. And then if we say that the delta X delta Y, we can exchange to delta A, right? So if we can do this, then this is A cross B equal. So A cross B equal. Let me write the partial X first with negative partial X I. Let me write like that, minus partial Y J, and then plus K, and multiply with delta A. And then if we set up the magnitude, so if we take the magnitude value, so let me write this maybe there, resize a little bit. So if we write the magnitude value of the vectors of the A cross B, it means that we are going to take the vectors. So we have the vectors here, right? If we take the magnitude value, remember we have the square root of this squared plus this squared and plus this squared, right? So write all of that. So we are going to take the square root, and this will be partial x. But remember, this partial x should be in that point. Okay, I didn't write the point here, but let me just write. This is on that point squared, and then plus partial y xy squared, and then plus 1. Okay, so the k is only 1, right? And then multiply with delta a. Okay. So this a cross b, the magnitude value is, we say that this is the definition of the delta t, right? So delta t is that, okay, same. So basically, we are going to exchange this delta t into our limit equation. Okay, we change to limit equations, and then we have our surface area becomes this. So this will be the area of the surface with the equation z equal function of x1. So we state the function as a function 2 variables. So this will be the surface. The partial both are continuous, and the area of surface we could just take the double integral. D can be, we can take that as a dx dy or dy dx, depends on our formulations. And then we say this is partial x squared, partial y squared, and plus 1.
Formulate my question again. When do we have to do like the integration first with y and then with x, or vice versa? Like, what is the criteria for doing?
There is no like specific criteria. Like it depends on how it looks like in the function. Sometimes it will be like dx dy, sometimes dy dx. But if it is a constant, you can do both. You can do either way. Yeah. So if you see the area that it encloses the rectangle, if that is fixed, then you can do both dx dy or dy dx.
Professor, so
Yeah.
So that formula we want to calculate the area
Yeah.
above.
Yes, like the surface. Usually we focus on finding the volume, right?
Yeah.
So this is only the area, this area. Yeah. So for example, if we look here, maybe not this one, maybe that one. So that area, the blue one. And depends on the endpoint, we can focus on like maybe only up until 0 to 3 on x, or maybe 0 to, or maybe negative 2 to 4 in y. So that will be our x and y, and our dx and dy. Okay, but I think the most like the next question will be that area can also be a function, and we need to do the exactly the similar thing with the conversion. If we need to convert, okay, or if we need to switch x and y, then we can do also.
How about like we have the a function s limit? What is that one?
Oh, this one? Yeah, this is the definition. Okay. So this is, if we take this and change this with our approximation, which is this. So basically the same thing. We put everything, this one inside that, and by definition, limit and sum becomes the double integral. This one here, these two sum become double integral. It's the same thing with this one. Okay, that's the definition. The same thing with this, and we can write this.
So A and B, it is two vector over there, right?
Yeah. and B. Yeah, it's a little bit crazy from the factors. And actually that is from the area of the, we call it parallelogram. So if we have two vectors and we cross the two vectors and we compute the magnitude of that value, it means we calculate the area of that that covers by the A and B. So every time we have like this vector, I'm just taking this. Right? Generally, if we take this, I think you know that this is a we call this in English we call this a parallelogram. So this is the same. This is the same, like that. Okay, the same. So if this is a vector, the area is basically this. This is cross product. And basically what we did on this part, the plane is basically we created from these two vectors and then we find that that is the area. Okay. Okay, let's try to look at what would we have in some examples. Okay, and I think that will be more important. So we have like at least two examples as in the picture. And I've given the picture as well. So find the surface area of the part of the surface. You have the surface, okay, and then that lies above triangular region T in the xy plane. So the area that is on the region, which is projected from the surface, is this area. Okay? So we would like to know. So let's start with the this T. We have this X, right? And then we have our Y will be depends on X, right? So if we say that the 0, 1 is our constant, then this part here from y equals 0 to something over here will be, so y equals 0, go up until this line, right? So it's until the X. So we could write first, okay, the partial. So partial X is that, and partial Y is just 2. And then we write the area, double integral, and let's just say T. And then this will be square root of 2x squared plus 2 squared plus 1 and then write dA. And based on our T within our triangular region, we could change T using that formulation. So this will be using constant X. So this will be dy dx. Now to solve this, all the knowledge from the previous double integrations could be worked. So sometimes maybe if we take this, maybe it will not work unless you switch. So you can switch. But I think this will work. So we can write here the T, we write 0, 1 and 0x. Okay. And this will be 4x squared plus 5 and dy dx. And I think this will be quite simple. So this y means that there's no y here, so we just add y and then we plug in x at 0. Okay? So we have 0, 1, and then x. Oh, wait. Okay. And then we have dx, right? And how to solve this? Basically, you need some techniques from calculus 1. Just substitute. Okay, substitute. So we can substitute this, which means we have 8x, and then we have 1 over 8. Okay, so we can substitute. U is 4x squared plus 5, so du will be 8x dx. So this will be 1 over 8 square root of u du, or we could this will be half plus 1 is 3 over 2, 3 over 2, so 2 over 3, so 2 over 24, and this will be 4x squared plus 5, 3 over 2, from 0 to 1.
Sorry, what did the tool change the boxes, right? When we're doing the substitution?
Yeah, I would like to change from this one, but I changed back to x, so I will use the same. Well, you can change u to like x to u.
But the answer would be still the same, right?
Yeah, it's still the same. So, for example, if I say that this is changing the, for example, this is x equals 0, means that u will be 5. When x equals 1, this will be 9, right? So this will be 5, 9. You can compare later. So this will be 4 plus 5 is 9. 9, 27, right? It's 1 over 12, 27. And then this will be minus 5, 125 square root is 5 square root of 5. And if we check from this part, we can get from 5 to 9. Oh, this was the same, 2 over 3, so 1 over 12, right? So this will be, yeah, the same, right? So 1 over 12, 27, 5 square root of 5. Okay? So both ways, okay. So if you want to use x, it's here. If you want to change all to u that way, same result, same conclusion. Okay, I think no problem here, right? Substitution, okay. You need more review, please, if you think you need, and to check your notes. Okay. And this example, the example 2, if we check here, okay. Find the area of the part of the paraboloid. We have this x squared plus y squared, that's our paraboloid. Lies under plane z equal 9. So z equal 9 here, and below z equal 9 there will be like a parabola, or paraboloid to be precise. And we would like to know what will be the area of this paraboloid, which means the whole thing here, we want to find the area. So sometimes if you see something like this, or even from the function, if you think that if we can convert this to the polar, and if it is easier, then we can convert it, okay, convert to polar. I think this x squared plus y squared is exactly circle that we can convert to polar, okay? And I think that will be easier to do that. Okay? But before we convert to polar, we write first the surface area formula, okay? The area formula. So we can write first, okay? Just to make sure what kind of function we have. So this is function. So partial x will be 2x, partial y will be 2y. Okay. So area, we can write just write d first. Okay. We don't really care much for the first part. Just write d. We care only for the formula first. Okay. So write 1 plus 2x squared plus 2y squared dA. And then we can, let me write a little bit left. So this will be d 1 plus, let me write, because both are 4x squared and 4y squared. So I will write 4, and then this will be x squared plus y squared dA. Okay. Now I would like to convert to polar. So basically, the idea for the surface area is only this part. The rest is basically solving using double integrations. We can convert to polar, or we can reverse dx dy or dy dx. Okay. So the idea is you put this first, finding the partial x or partial y first, put into this, and that will be your surface area. Okay. After this, then this is the how to solve, the process. So basically, the surface area part only up until this. Okay. So after this, then we try to solve the solution. Now, if you look here, then this is just like our regular problems in polar. Right? So we say that we can convert to polar. So we can convert to r squared. Right? So the d and dA, we can also see from what we have here that because we have z equal 9, that will be our standard. So z equal 9, if we find the intersection here, then the radius should be 3. Right? Radius should be 3. Right? So we can write that as our restrictions. So when z equal 9, then we have this circle formula, which is r equal 3. And there is no other restrictions. So we calculate from r equals 0 to 3. And the circle is a full circle, so from 0 to 2 pi. So we convert that polar. Okay. So we convert the polar, becomes 0, 2 pi, 0, 3, and then the inside becomes 1 plus 4r squared, and then don't forget r d theta. And similarly, we see that this integration can be solved through substitution, right? 4r squared is r, so let's substitute. We can substitute that part. And then I think we can also separate. So we can separate the theta over there because there's nothing left, right? And all the endpoints are constant, so we can separate this. Or let me write r in the first place. So let's say we have so we are going to have 1 over 8. So 1 over 8. And then this will be square root of u, okay? Or if we would like to take when x or when r is 0, u is 1. When r is 3, u is 37, right? So this will be 1 to 37 du. So we have 1 over 8. This will be 2 over 3. And u over 3 over 2, right? From 1 to 37. So this will be 1 over 12 is 37 square root 37 minus 1. Okay, multiply with, so let me complete the answer. 2 pi multiply with 1 over 12, 37 minus 1. This will be pi over 6. Oh, well, let me resize first to make it clear. Yeah, that is the answer. Okay, I hope you can understand my notes here. This part is only for the substitution part, and then afterwards we multiply with this 2. So that's the answer. Okay. Any questions so far? No. I would like to move to new sections, the triple integrals, just for just a few introduction and then finish. We can continue tomorrow and have, I think, maybe giving more exercise on this surface area also tomorrow. Okay. So today is 7 December. 22 our finals. Okay, 22 of December. Okay, so yeah, hopefully I can finish just triple integrals, and then just after that one more about Jacobian, and I think that will be the topics for chapter 15. So I skip 3 or 4 sections, 3 or 4. Okay. Okay, let me just go for a little bit introduction for triple integrals, just to show you what will be our focus. Okay. So actually, if we try to build up like a rectangular shape volume like this one, and if we break the volume, we could have this small rectangle that is, its dimension will be described as delta x, delta y, and delta z. We say that this will be bijk. Ijk means with 3 axes. And suppose that if we have B on this XYZ, let's say the X is from A to B and Y is from C to D, and then we have Z. Let's just write with R, okay, just to make it different from X and Y. So we have a closed solid B, which is, we say this is contained in a box, okay, and then divide B into small box or sub box, which the volume for the small box is delta, this is volume of sub box. And then if we take the point on each x, y, z as x, I, j, k, and then y, I, j, k, that's a sample point. If we take that, so we would like to see that we are going to have a triple Riemann. So we describe the delta V in triple Riemann from x, y, z. So we have Riemann, the sum, I, j, k. So this will be L, M, N. And this will be our function wait, it's gone. Okay. And then we can take the definition of the integrations. So triple integral of f over the box, over the box B is the limit L, M, N going to be infinity of this. This is this will be delta V. Okay, so I think I will end until here. We continue tomorrow.